All of you, please rename yourself and mute your mic. My screen is shared, right?
Yes.
Okay. Yeah, so see, we recall yesterday we saw this, right? F from x to y is a function, and we have a subset of x, right? So we have a subset of x. And what is f of a? So when do we say that y belongs to f of a? Right? F of a is a subset of y. So how do we write this? Y belongs to y such that, how do we write? Yes, Parul?
And there exists a small a in capital A such that y is equal to f.
Yes, there should be some a here, right? Small a in capital A such that y equals to f of a. So if I take some element here, it does not have a pre-image in A, then it is not in f of a. So this is f of a. So it's a image of A, image set of A, right? All elements of A going this way. So there exists A in A such that y equals to f of A. So what do you mean by saying that y does not belong to f of A? If y belongs to f of A, then this condition holds. This means that y belongs to f of A. What do you mean by saying y does not belong to f of A, Sandhya?
Y in Y such that for all A in A.
Now I'm taking, yes, y is in y, but y does not belong to f of A. This means what?
So for all A in A, Y not equals to F of A.
Given any a in A, y is not equals to f of A.
F of A.
Yes, you take any a here, right? Any a here, and but y will not be equals to f of A. F of A will never go to y, right? So y in f of A, that means there exists some preimage in A. There exists some A in A, so that A is a preimage of y. Okay, and then we had considered some examples. We had taken one example, right? F from R to R, f of x equals to x square, and we had taken A equals to let's say take A equals to 1. What is f of A? Very easy, right? Pragya, room number 1. Or sorry, room number 10. Pragya,
So 1.
1. Yeah. And what if I take A equals to minus 1?
So
What
it will be
is,
same one.
it is same, right? F of A is 1, right? Okay. If I take A equals to 0, 1, close interval 0, 1, what will be f of A?
So 0, 1.
0, 1, right? Squaring. So if I square any number, if x is between 0 and 1, what is x square? Right? F of x equals to x square. So x square also is between, okay, 0 and 1 are included. So x square also between 0 and 1. Good. Now if I take some set, let's say b equals to 0, 1, minus 1. What is f of b? F is x square, right? Yes, room number 3, Aarti. We did yesterday, no?
0, 1.
0, comma 1, right? And if I take b equals to, say, minus 3, comma 2, then what is f of b?
0, 3.
0, comma 3. Okay. How many of you agree with her?
No, sir.
No,
9.
given 0,9. Okay, good. Yes. How did you get it, Arti? That's correct. 0,9. But how did you get it?
सर -3 का स्क्वायर 9 और स्क्वायर 0 से शुरू होंगे,
हाँ,
नेगेटिव एलिमेंट तो नहीं आएंगे स्क्वायर में।
नेगेटिव नहीं आएंगे, बट हाउ डू यू नो 0 to 9 सब आएंगे?
सर बिकॉज
हाउ?
0 का स्क्वायर 0 इसमें आएगा,
हाँ,
1
0
का
आएगा, राइट, गुड। 1 का भी आएगा, 2 का भी आएगा, राइट, गुड. Any other way? Somebody checked any other way? 0, 9. What is the process you follow? हाँ, संध्या. Tanya.
Sir, I will divide the x into two parts. First part will be that x lies between -3 to 0. Then x lies between 0 to 2. Then I
हाँ,
split both sides and get it.
okay. I don't know if it is my connection or Tanya's, but voice was breaking, but I could get what she was saying. So what she said, uh, I hope my voice is okay, right? My connection is fine. What she said, she break in two parts. So she takes here like -3 to 0, and then union taking 0 to 2. Is that what you said, Tanya?
Yes, sir.
Yes. Then Tanya says that if x is between -3 and 0, right? Then what is x square, right? X square will be, even if I square, it will be positive. So 0 to 9. And this will give me uh, x square will be between 0 to 4. And I have to take the union of this, right? So it will be 0 to 9. Is this how everybody checked? Who checked like this? A good way to check, right? If we just ignore the negative numbers, we just take 0, 2, then it's a problem. We'll take 0, 4 only. But then -3 square also is there, which is 9. -3 is there in B. So f of -3, that is 9, is there in f of B. So we need to do like this. Yes. Then I ask you to observe anything. Did you observe any relation while doing examples? Ritu, you have some observation? On all these examples or whatever you tried yesterday, is there any observation? Whatever observation is there, whatever your whatever your thoughts are, you can share. Priyanshi?
So the approach which I thought is that x square is an increasing function, sir. So the lower will occur at the lower point and the upper will occur at the upper point of the domain only. That is one.
Huh.
So we can directly take the range to be first point of the range will be at the lower point of the domain, that is 0, and all
Huh.
the points in the range will lie between the range of 0 and 1 only, as it is an increasing function.
This one, no?
Yes,
But
sir. X square.
but then what about this? What about this? Did you get this answer? Same. 0, 9. Okay. Any other
The
observation?
Sir,
Ah,
x square is always positive now.
x
So
square is non-negative. X square
yes,
can
sir,
be
not
0.
negative. So
Ah.
like 0 point is also occurring in -3 to 2. So it will start from 0 and
Hmm.
like the square is positive number. So the
Hmm.
highest part will occur at -3 only.
Yes. Okay. Yeah. Good. That's one observation. But did you observe anything like taking examples? Who said yes? I think Priyanshi only, huh? Vishal has some observation. Yes, Vishal.
So we start from zero range from 0 to maximum of
Huh.
these B element,
Okay. You
like
are saying about
minus
this,
3
no?
comma 2. Yes,
Yeah.
sir. Minus 3
Okay.
comma 2 we take 0
We.
comma maximum of minus 3 comma 2.
Uh-huh.
नहीं पॉजिटिव
Uh,
में -3 comma 2.
-3 to 2. Yeah. Yes.
इसको
But
पॉजिटिव कर देंगे तो वो उसका रेंज 3,2 के मैक्सिमम में हो जाएगा।
Right. 3,2 is not in range. I mean,
अब सर जो माइनस पॉइंट है उसको भी हम प्लस कर दें अगर, तो
हाँ,
जो
so like it is 0 to 3. Same you are saying, no? Instead of -3 to 0, you can take 0 to 3. Right? यही बोल रहे हो ना? हाँ. हाँ, but my question was probably different. What I want to say, you have given a written assignment, right? In written assignment, you have some set operations. What are the set operations we had seen in written assignment? Between two sets, we have some operations, right? Sumit, if I have two sets, A and B, like what are the operations?
Complement.
I can take complement, right? Any other thing? A is there, I can talk about A complement. Then I have two sets. I can talk about subsets,
Union.
right? Yes, union and intersection, right? And also in discussion, there was one set difference.
Set difference.
So there are many operations in sets, right? Now we can check how F behaves with these operations. For example, if I consider a subset, so if I have, if suppose A is subset of B, then what can you say about FA and FB? That is one question. Is there any relation? Do you think is there any relation between this? Can you observe any relation? We have already taken some subsets. Shivam,
FA is subset of FB.
FA is subset of FB. This is what Shivam says. And you can observe also. See, this A is a subset of B, right? One is already there here. What is F of A? 1. What is F of B? 0, 1. So this is subset. Here also 0, 1 is a subset of A is a subset of B. What is FA? 0, 1. What is FB? 0, 9. Right? So this 0, 1 is subset of 0, 9. So this is what one observation we can see from examples. But now we have to prove this. So if A is subset of B, then FA is subset of FB. What is given and what we have to prove? Can anybody say? What is given first and then what we have to prove? Aisha?
Yeah, we have given A is a subset of B and we have to prove F of A is a subset of F of B.
Very good, Aisha. Yes, correct. We have given A is subset of B and we have to prove this FA is subset of FB. So where do we start? Yes, Sheikh Faisal.
सर वहाँ पे आपने स्क्वायर लिखना भूल गए हो
Where?
ऊपर वाले पेज में 0 लेस देन एक्स स्क्वायर.
Okay. Thank you. Sorry. Yeah. Good. Thank you very much. Yeah. So we have to prove this. FA is subset of FB. So where do we start? Sheikh Faisal, can you tell?
Yes sir, we'll take an element from f of a and we'll
So
prove
you want to give notation? F of A. Take some element in F
yes,
of A.
small a belongs to f of a.
Small a. Okay. F of A is subset of what?
F of a
F
is
is a
subset of b.
F of A is a subset of where? A is a subset of X.
X.
So what is F of A subset of?
X domain.
X domain. Is it? Check again. F of A. This is F of A, right?
Sorry sir, yeah,
A we are
domain,
taking here.
codomain.
Yeah. Codomain. Yes. So
Y.
yes. So it is a subset of Y. So we take some appropriate notation so that we don't get confused. You can take X or A. It's not
Small y.
fine. It's fine. Not a problem. So I take small y. So I start with let y belongs to F of A. Okay, good. Thank you, Sheikh. All of you understand this? See, we started with whatever we wanted to prove. You know, we go in a picnic, we take our lunch box. We don't open the lunch box and eat it right away. And we first go in the bus or train and then we go to the picnic spot. And then when lunch time is there, we open our lunch box. So this is our lunch box. It's given to us. So we put it aside. This is what we have to prove. So I have to prove some set is a subset. So I start with an element. Okay, so we can take X or A or anything, but most appropriate notation would be Y, because f of A is a subset of Y. We are taking Y, so I'm just taking Y so that no confusion is there. That's the reason, nothing else. We can take any notation. Okay, now what does this mean? See, every time I'm asking question, did you observe? We are giving the proof, we are asking questions. Now Y belongs to f of A. What does this mean? Ankita? Can you tell? Yes.
Yes, sir.
Yes. What does this mean? Y belongs to f of A.
Any
Okay.
arbitrary element
Uh,
of a FA.
it's an element, but then Y belongs to f of A. That means what? We discussed, no, just now. Okay. Just pay attention. We ask somebody. Ramesh, can you tell?
There exists A belongs to A such that Y is equal to f of A.
Good. So what Ramesh says that there exists A in A such that Y equals to f of A. Is it clear now, Ankita? We have just seen, right?
Yes, sir.
So what are the elements of FA? So Y is in f of A means what? Y is a pre-image of some element in A, right? Okay. Ramesh said A, but I'm going to use the notation X. Why I'm using X? Because there are two sets, A and B also. So if I use small a, then I get confused. A in A, so I use this. Okay. What we have to show? So here X is there, right? So I've changed X. Instead of A, I'm writing X. What do we have to show? Why, where we have to show Y, Sumit?
Y belongs to f of B.
We have to show that Y belongs to f of B. This is our target in mind. So that means what, Sumit? What I have to show?
There exists some element belonging to codomain. Sorry, set of B that
Uh,
has B.
that is whose image is Y.
So, yes, whose name is Y.
Yes. So what Sumit is correct. So he says that this means there exists some element should be there in B,
B.
such that Y equals to f of this
Y
some
equals to
element,
f of some element.
whatever we put here, right? Some element we have to put. Okay. Uh, so how do we proceed? Can I find some element in B such that Y equals to that element? Do you see? Right? Let me repeat. We have to show this. So we started with some element Y in f of A, but this means that Y, there is some X in A such that Y equals to f of X. Definition of f of A, right? But I want to show Y is in f of B. Y is in f of B. That means I want to produce an element in B such that Y equals to this. Now, how do I get an element in B? Can you find out the answer? Can you think of an element in B such that Y equals to f of that element? Ashwini,
Yes, sir.
yes, what is your answer?
There is X belongs to B because A is subset of B.
Good. Ashwini says because since A is subset of B, so X is in A, so I have X is also in B. Then Ashwini, you want to continue? So X is in B.
There exists X belongs to B, Y is equals to f of X.
So X belongs to B and Y equals to f of X. So this implies that Y belongs to f of B. How many of you understand? And those who want me to repeat, say no. I'll repeat once again. Okay, good. Nobody wants me to repeat. Everybody understands? Okay, then we have to repeat without writing. So let me wipe out this everything. Okay. So can somebody repeat? I'm clearing the feedback. Doesn't matter if you get stuck. Just try. Today is now first and last time to try. Of course, you will try in your own classes now. But here, yes, Mujtaba.
Yes, sir. So
Huh.
I've been given that A is a subset of B, and we have to show
Slowly,
that
huh?
f of
Slowly,
A
step by step. Yes. So we are given that A is subset of B, and we have to show that
f of A is a subset of f of B.
f of B is good.
So for that, we'll have to show that if there's an element x belonging to f of A, then x belongs to f of B as well. So
No, if some element belongs to f of A, then it belongs to f of B. Huh. So start with some element.
So we'll consider y belonging to f of A.
Oh, let y belongs to f of A. Yes.
So y belongs to f of A. So there must exist a x belonging to A such that y is equal to f of x.
F of x, yes.
Yeah. Now A is a subset of B. So x belongs to A, which implies x belongs to B as well.
Yes.
So and we know that y is equal to f of x.
Yes.
So there exists a element x belonging to B such that y is equal to f of x. So y belongs to f of B. So if
Yes.
y belongs to f of A, then y belongs to f of B, which implies f of A is a subset of
Subset of f of B. Yes. Directly then last we can say that y equals to f of x, and now x belongs to B. So that means y belongs to f of B. Okay. Bhakti, you want to try? You want to repeat?
Yes, sir.
Yes.
If A is a subset of B, then f of A is a subset of f of B. Here,
Yes.
A is a subset of B is given, and we have
Excellent.
to prove f of A is a subset of f of B.
Yes.
हम यहाँ पे कोई भी एक एलिमेंट लेंगे जो f of A को बिलोंग करता है कि y is a subset of f of A, then we can say that
y belongs to f of A.
y belongs to f of A. Then we can say that there exists x belongs to A such that y is f of x, y is equals to f of x.
Yes.
Since we know that A is a subset of B, therefore x belongs to B also.
Yes.
Then there exists x belongs to B such that
Now,
y is the.
I'm stopping you. Now we don't say there exists because x already existed, right? ऑलरेडी मिल चुका है वो एलिमेंट. हाँ, x there exists x ही नहीं. अब तो बस इतना ही बोलना है कि x belongs to B and y equals to f of x.
F of x.
Yes.
Then we can say y belongs to f of B.
F of B, very good. Yes. Yeah, so f of A is subset of f of B. Good. Okay. How many of you are confident that you can do it? I will erase it. I wiped out. So I want you to do it without writing. Okay. And then you can write down. First, go through this in your mind. Okay, take 30 seconds. Go through this in your mind, and then you can later on write down, not now. Okay, once you take your time, don't say yes quickly. Once you are done, say yes. Okay, 30 seconds are up. But if you think you can clear your doubts in discussion, if it will be clear, click yes. Okay, right. So we have seen that like f we have taken one relation, subset. So in subset, F is very good. So if A is subset of B, F behaves well. F of A is subset of F of B. Now let us take union. So what do we have to check now? Can anybody tell me? Now we are taking the relation union. So what is that we want to check? Jainam?
If A is a subset of B, then if A union FB is a subset of FB.
No, subset we are not taking. Now we are just considering union. Okay. So what he says that F of what did you say at the end?
FA union FB is a subset of FB.
Subset or equal? So
Sorry, equal.
maybe we can check. I mean, we have to check this, right? Yeah. So now we want to check if we take union of two sets, A and B, right? And then apply F. And on the other hand, we take first apply F. We take their images and then take the union. Is it going to be same? That is a question. You understand this? Right? We are taking two operations. So does F behave well with union? So if you take two sets to take union and then take the image, or you take the image and then take the union, will it going to be same or not? That's a question. Before we check this, one more question I have. If you see a statement like this, what can you ask? We have discussed so many times something like this. Such a
Converse.
statement is, exactly, converse. Good. Who answered?
Aisha.
Yeah, Aisha.
Answer.
So, what is a converse, Aisha?
If F is a F of A is a subset of F of B, then A is a subset of B.
Yes, if F of A is a subset of F of B, good. Now you started thinking that way, right? So whenever you see such statement, you always ask, what about the converse? If we are given this, can we say that A is a subset of B? So this you think, right? Check and discuss. Okay, think about it. Now we want to check this. What happens with the union? So how do we show this? Any idea? How do we show this? I'm not asking the proof. I'm asking how to proceed. What is the meaning of showing that these two things are equal? What are these two things? Charvi?
So both of them are subsets of each other.
They are sets, right? You observed, yes, this is a subset of Y, right? This is also a subset of Y, this is a subset of Y. So they are subset of each other. So Charvi, where do you want to start with which side?
F of A union B is a subset of F of A union F of B.
Okay, so our subtask. Okay, so first we show this. Okay, thank you, Charvi. Clearing the feedback. Where do we start? Now we want to show this. Where do we start? Just starting. I'm not asking the entire proof. Just start. Begin. How do I show one set is a subset of other set? Why only few? I'm not asking complete proof. Sumanyu?
Sir, we will take any arbitrary element in FA union B and show it as a part of FA union FB.
Yeah. So can you give a notation for some element?
Say that X be a part of FA union B.
X belongs to F of A union B. But F of A union B is a subset of which set? If F is a function from X to Y,
then it is a subset of range of F.
Subset of range of F, right? So codomain, right?
Yes.
So codomain is Y.
Yes.
Codomain is yes. F is a function from X to Y. So all these images are subset of Y. Do you agree, Sumanyu?
Yes, sir.
So do you mind if instead of X, if I take Y?
Sure.
Because just to avoid confusion, right? So
Yeah.
I prefer y. You can prefer x or any element. It's fine, w or whatever a you can take. But I'm just taking y because of this. I know here there are this y, right? Y, f of a. So there is a here or x here. Okay, y is in f of in b. What does this mean now? Can you proceed?
Sir, so this means that there is an X in A union B such that
Yes,
Y is equal to F.
very good. There
Fx.
is an x in A union B such that y equals to f of x. So Manu, where do we have to show y?
You have to show that Y is part of FA union F2
So we have to show that y is either in f of a or
or
y
in
is
F of
either
B.
in f of b. Yes. So now can you say anything?
Yeah, we can say that X is either in A or in X is in B.
So we have two cases, right? X is in A
Hmm.
or x
X
is
is
in
in B.
b, right? Okay. Okay. Ah, good. So Manu, I'll ask somebody now. Okay.
Okay.
Uh, uh, Yashraj, you want to continue?
Yes.
Uh,
So X A and B में belong कर रहा है, so
and नहीं है or.
yes, or
It's a
sorry.
union, right? Yeah. So either x is in A, we don't know which side. So either x is in A or x is in B, but it will be in at least one of the two. It can be in both, but we're not sure. So I cannot say and. It's all. Okay.
Yes.
So how do we proceed?
है and और है, तो मतलब इसका एक प्री we can say.
Sorry, Yasraj, I'm going to ask somebody else because your voice is breaking. Okay. So let me ask. Yeah, Tanya.
Sir, we already know that y is equal to fx when x
How?
belongs to A or B. So we can break like x belongs to A
Uh,
such that y is equal to fx, or x belongs to B such that y is equal to fx.
yeah, so we have two cases. If x is in A, what can we say about y? Y equals to f of x. We already know. So what can we say about y? Where does y belong? Tanya, where does y belong in this case?
Range, sir.
Range, of course, yes. But is there anything else we can say? What we have to prove?
Sir, y belongs to f of A.
Yes, right. So y belongs to f of a, right? If x is in A and y equals to f of x, then I can say that y belongs to f of b. What is our second case?
That y also belongs to f of B.
Not also. If y is in x is in b, second case is what? X is in b, right?
Yes, sir.
Then what we can say about y? I know y is equals to f of x. What can I say about y?
That y belongs to f of B.
F of b, yes. So in first case y belongs to f of a, or if the second case is there, then it is f of b. So what can we say about y
Sir,
now?
as there is or, so we can say that y belongs to f of A union f of B.
F of b, yes. Okay, f of a or f of b. So y belongs to f of a union f of b. How many of you understand this? Okay, I'm clearing the proof. I want one of you to repeat. Okay. Go through this in your mind. Take 10 seconds. And somebody, when you are ready, you click yes. I'll ask somebody to repeat. Yes, Advait, you want to try?
Yes, sir. I'd like to try.
Yeah.
So, sir, to first show that f of A union B is a subset of FA union FB, we
Mhm.
take a Y belonging to f of A union B,
Mhm.
and we say that there exists a pre-image corresponding to that Y. That is that there exists an X belonging to X such that
X belonging to?
No, the X belongs to A.
A or where? Where did you start? Y belongs to, what is your first step?
Sorry, it belongs to A union B.
So first step is Y belongs to f of A union B. So there exists X in A union B such that
Y is equal to fx.
fx, yes. Now proceed.
So, sir, from here we can further say that x is either belonging to A or
Mhm.
X is belonging to B, since it belongs to the union of A and B. And then we can say that X belongs to A such that Y is equal to fx, or X belongs to B such that Y is equal to fx. And then we can further say that Y belongs to FA or Y belongs to FB. Thus, Y belongs to FA union FB.
Y belongs to fa. So first case is if X is in A, but
Yes,
then
sir.
Y equals to fx. So if X is in A and Y equals to fx, this gives me Y is in FA. Or
Yes.
what is the second case? X is in B,
And Y
right?
is equal to fx, then
Y equals to fx. Then Y equals to, Y belongs to
FB, sir.
f of B. Yes. So what are the two cases? Either Y belongs to f of A
Or Y belongs to F of B,
or
and
Y
that
belongs to
that Y belongs to FA union FB.
FA union FB. Okay. Take 10 seconds. All of you, 15 seconds. Go through this argument in your mind, and if you are ready, say yes. Or if you can think, you can discuss in the discussion, then say yes. If it is clear. Right? Do not write. First, try to go through it in your mind, and then you write down. Okay. Okay. So what we have to show next? Now we have to show this. Next thing, f of A union f of B is subset of f of A union B. How do we show this? Clearing the feedback? Answer now. If you have idea about the second one. So first one done, right? Yeah. Swati, room number 4.
So we will take an arbitrary element y such that y belongs to f of A union f of B.
Okay. Yeah, proceed that way. Yeah. So y belongs to FA union FB. So y belongs to
FA or y belongs to FB.
FB. Okay. What is first case?
Y belongs to FA.
Okay. Suppose y belongs to f of A, then
There exists x belongs into A such that y is equals to FA.
okay.
And similarly for y is equals to FB, there
Yes.
exists x in B such that y is equals to FB.
Yes.
And
So in both these cases,
yeah,
okay, good.
therefore x belongs to A union B.
Either x is in A or we are getting some element in A such that y equals to, if we are getting in A, can I say that x is in A union B?
No.
No?
Yes.
Why?
Because it's all right. So if it belongs to A,
Yes, so if x is in A and y equals to fx, I can say that x is in A union B also. So in that case also y is belongs to f of A union B. What is the second case?
Same for the second case is x in B such that y is equals to fb. So x
Yes.
belongs to union B.
Okay, good. So that way also we can do. Is there any other way? Anybody has any other argument? So how many followed? How many of you followed what she said? Yes, Pritika.
So I guess she meant f of x, but she was saying f of b.
Yeah, I know. She said f of a, but that's just notation. Yes.
Yes, sir.
Yeah, x and b. She said in the other case. Yeah. Uh, so what is the relation between A and A union B? Pritika, can you tell?
Yes, sir. So it's the subset of A union B.
A is a subset of A union B, right? We have done
Yes, sir.
this. X in A. But what does this mean? X in A or X in B? But X is already in A, so it is in union. Right. So if A is a subset of A union B, what can we say if we apply F?
F
I
of
know.
A
So by how? F of A is what?
subset of F of A union B.
How can you say this?
So we applied function.
But have you proved this?
Not yet, sir.
Not yet. If A is a subset of B, then we have proved this. C number 1.
Yes, sir.
Yes. Oh, okay. How many of you see this? A is a subset of A union B. I can say that F of A is a subset of F of A union B. Because already we have proved, right? F behaves well with subset. And this is a subset. Just notice this. Is it clear? If not clear, say no. If it is clear, say yes. Okay, right? So A is a subset of A union B. So F of A is a subset of F of A union B. Can we say anything else? Can we say anything else, Jainam?
B is also a subset of A union B.
So similarly, B is also subset of A union B. So then?
F of B is also a subset of F of A union B.
How?
By theorem number 1.
By 1, we already proved this. So, so now what? Jainam, can we conclude what we want to show? Sakshi? Room number 9. What do we want to prove?
F of A union B subset of F of A or F of B.
नहीं, ये तो कर दिया था. ये कर रहे हैं अभी, right?
Yes, sir.
But what do we know? Is F of A subset of F of A union B?
Yes, sir.
Yes, right? We have shown this. What about F of B? Is it subset of F of A union B?
Yes, sir.
Yes. So what can we say?
F of A union F of B is subset of F of A union B.
F of A union B. Yes. So it is like this, right? If I have C is subset of X and D is also a subset of X, then we can conclude that C union D is a subset of X. Right? So we have F of A is a subset of F of A union B, similarly F of B. So their union also is a subset of F of A union B. So this is one way. We already done this, so we can apply this. Or as the other way, what she said, we can try with one element here and then we can show it is in F of A union B. So both way we can do, right? But this way it is easy, right? We already proved this. How many of you understand? Yes, Sumanyu?
Sir, I had a question. I was trying the way that you just said, pick an element in FA union FB and then show it as an A union B. Then
Yeah.
I came across a problem while doing this.
Okay.
So if we take a Y in FA union FB, it
Hmm.
will be either part of FA or it will be in FB.
Hmm.
But and then if we consider the cases that if Y is in FA, then there exists some X, and then we say if Y is in FB, then there exists some X. But these two
Hmm.
X's may not be the same, right?
But I want some X in A union B. You have found an X in A, right?
Yes.
Can I say that
I
X also belongs to A union B?
yes, okay.
Yeah, so that's what we
Hmm.
discussed. So it is like
Okay,
this.
okay.
This will be Is it clear?
Okay.
Yeah.
Got it,
Okay.
got it. Okay.
Yeah. Okay. How many of you are understood this? Okay, good. So now about intersection, what do we have to show now? What do we want to check? Adya?
Yeah, so for intersection, we need to show that f of A intersection B is equals to intersection of FA and F.
Yeah, we want to check this.
Okay, so
Okay. Yeah, thank you, Adya. How do we check this? Room number 3, Pooja. Pooja.
First, check element from belongs to F of A intersection B, then we show it in F of A intersection F of B.
F of B, yes, we can do this. We can take F of A intersection B and then show that Y belongs to F of A and okay, intersection F of B. Marshi, same thought?
Yes, sir.
Okay. Does anybody have any other approach? Wait, Advait, question or answer? If you want to answer, say yes or no.
Yes, sir.
Then wait. Let me ask you. I already asked you one question. Divya?
अगर हम एफ ऑफ ए इंटरसेक्शन बी को एफ ऑफ ए इंटरसेक्शन एफ ऑफ बी के सबसेट और एफ ऑफ ए इंटरसेक्शन एफ ऑफ बी को एफ ऑफ ए इंटरसेक्शन बी के सबसेट से दर्शाए दी
हाँ, वो तो करना है, चेक करना है. So first we are showing this f of a intersection b. We are checking this. F of a intersection b is subset of f of a and f of a intersection f of b. So any other Advait, you can. Do you have any other approach?
Sir, I was trying to use a similar approach to the one that you discussed for this. That
What is that?
says A intersection B is a subset of A, and A intersection B is a subset of B.
Yeah.
So by the first result, we can say that F of A intersection B is a subset of FA, and F of A intersection B is a subset of FB.
Yes. So yeah. So see, we've already done this, right? We can think about this whenever we see intersection and union, right? We think about the relation between the sets. We know A is subset of A union B and B is subset of A union B. Now here we don't have union, we have intersection. So is there any relation between intersection and this? So Advait is right? A intersection B is subset of A and B. So we can apply one again. So by one, what we have, F of A intersection B is subset of F of A, and F of A intersection B is subset of F of B. Then what we can say, Advait?
So then we can say that F of A intersection B is a subset of FA intersection FB.
It is subset of both FA and FB, right? So it is subset of intersection.
Yes, sir.
So we have proved what we have proved. Advait, what we have proved?
So that F of A intersection B is a subset of FA intersection FB.
FA intersection FB. Okay.
Yes.
Okay, thank you. Sumit. Okay. How many of you understand this? We can try this way also, not a problem. You can check this way by taking an element also. That way also is possible. You can take y belongs to f of a intersection b, so y equals to f of x. Or there exists x in a intersection b, so that y equals to f of x. But then it means what? Then show that y is in fa and y is in fb. That way also is fine. But we can be smart, like we can observe. Already we have proved a intersection b is subset of a. So f of a intersection b is subset of f of a. And similarly, it is also subset of f of b. So it is subset of both. And so it's subset of intersection. Do you understand this? Right? You can try for your practice. You can try using element also, not a problem. But then this better way, right? Already we have done observe. Yeah. What we have to show next? Yeah, Sumit, can you tell?
Yes, sir. Now we have to show f of a in intersection f of b is a subset of f of a intersection b.
How do you show that? Sorry. This is what you said, right? Yeah. How do we show this?
Sir, I will use another first method. That is, I taking an element from f of a intersection f of b, and then I will show it in f of a intersection.
So take an element. Y belongs to?
Y belongs to f of a intersection f of b.
Then?
Then there exists some x belongs to a intersection b.
A intersection B. Okay. So again. Y belongs to?
Sorry. There exists x belonging to f of a intersection f of b.
No, wait. Start again.
Yes.
Y belongs to?
Y belongs to f of a intersection f of b.
Y belongs to f of a intersection f of b. That means what?
There exists some element.
No. Wait. Intersection. Slowly, step by step.
Intersection. Y belongs to f of a and y belongs to f of b.
Y belongs to f of a and y belongs to f of b. Yeah. Then
there exists x belongs to a such that y is equal to f of a. Sorry, y is equal to f of a.
Y equals to f of a. Okay.
Okay. And here also there exists some x belongs to b such that y is equal to f of x.
Oh, is that same element?
Yes, intersection.
No, wait. So you have taken y here. Y is in f of a intersection f of b. So I have y belongs to f of a and y belongs to f of b. Okay, good. Then
there exists some x belongs to a.
So x. So let us call a. Right now it is in a, right?
So a
A
belongs
is in
to
a.
such that y is equal to f of a.
F of a. Okay, and
there exists small b belongs to capital B such that y is equal to f of b.
Okay, how many of you understand this? How many of you agree with this? And how many of you understand that I have taken here different notation? I'm not keeping x. Can I write x here, y equals to f of x, and the same x here, y equals to f of x? Right? So understand that. So here there is some element in A. Right? Here there is some element in B. So I've not written x. Because here I get x in A, y equals to f of x. I cannot use same notation. I don't know whether it is the same element or not. So some other element. So either use x1 or x2. Okay. So either use x1 in A such that y equals to f of x1. Or and use here there exists x2 in B such that y equals to f of x2. Okay, how many of you understand this? Now what do we do? Yes, Mustaba. How do we proceed?
Now we know that f of x, y belongs to both f of a and y belongs to both f of a and f of b. So that
That already
belongs to
done.
their intersection.
No. We already done. Y is in f of a and y is in f of b. Okay. Now y is in f of a, so there is some a in or x1 in a, so that y equals to f of x1. And now y belongs to f of b, so there is some b or x2 in b, so that y equals to f of x2. Now how do we do? Rachna?
Yes, sir. So from here we can say that y belongs to f of a and y belongs to f of b.
So y belongs to f of a and y belongs to f of b. Do you want to go back? Intersection. We started, we'll come back. We want to go here. So what does it mean by saying y belongs to f of a intersection b? This is what we have to show. What does it mean? I want to show that y equals to f of something. Where is this element going to come from?
A intersection b.
This is going to come from a intersection b. Now, is there any? I'm clearing the feedback. Those who have answers say yes. Tanya?
Sir, we can pick any x in A intersection B. It will satisfy the both definitions.
No. Then it is different. Then again, we are going back. Already proved this. Right? F of A intersection B, then it is here and here. No, that is fine. Now we are going back. We are starting from here and we are going here. So we started with y belongs to, we are proving this. So y is in FA, y is in FB. Y is in FA, so there is some A in A, so that y equals to FA. There is some B in B, so that y equals to FB. Now I want an element, y equals to, I want to write something. Y equals to something, f of some element. That element should be in the intersection. Swati?
Can't we just directly write after this step that y belongs to f of a intersection b, because we have x1 belongs to a such that y is equals to fx1 and
So I want to write this. So before that, I will write y is equals to f of something. That something should be in A intersection B, but I know x1. Where is x1? Or let us say A. Let us say A. A is in A, right? I don't know whether A is in B or not. I know that A is in A. A is in B. This is question mark. This is I know. Similarly, what about this B? Right? B I know. B is in B. But what about B? Does B belong to A also? It's a question mark. I don't know. How many of you understand that there is a problem? One side we have got A which is in A and y equals to f of A. I want something which should be in A and B. I don't know whether this A belongs to B or not. Here I have got B such that y equals to f of B. Now B is in B, but I don't know whether B is in A or not. So how do I produce an element in A intersection B? Will A work? I don't know. Will B work? I don't know. Yes, Advait?
So I was thinking if maybe we could take an element in the union, because we know that A intersection B is also a subset of the union.
But then union means what? Then how will you bring A intersection B?
So that if y is equal to an element, say that if y is equal to f of x, where x belongs to A union B, then we can also say that this x will belong to A intersection B. And
No.
then
Union. This is already there in union, no? Isn't it? A में है तो यूनियन में तो है, A is already subset of A union B.
Yes, sir.
B is also there in A union B. B is in B and B is subset of A union B.
Okay, sir.
But we don't know that we want in intersection, we want in both. So there is a problem. If you understand, there is a problem. If there is a problem, that means we are not able to prove. And we are not able to prove, that means we find some function. Take two sets, take a function, A and B. Can you think of this? Can you give an example of any function? Any function on any set x to y. Can we give an example? What is the first function that comes to our mind? First function, easiest one. Any set x and y. I'm not saying x is r or y is r or nothing, just two sets. Yeah. Ayush?
X square.
X square, yeah, but x square is, I don't know x and y. I'm not giving r to r. Any function, just two non-empty sets, x and y. Can you give a function? Swati?
Identity R to R.
Identity, we need domain, codomain, same. Divya?
Constant function.
Yes, good. X to y, you can always give constant function. Yes or no? Yes, constant function. So can you give a constant function from R to R? Yes, Swati, can you give a constant function from R to R?
0.
Yeah, f of x equals to 0, given any x in R, right? Yes. Now, Swati, give me two sets.
0, comma 1.
A equals to 0, comma 1, and B equals to?
0, 1, 2, 3.
I don't want subset. I want some different.
6, 4, and 5.
Huh?
3, 4, and 5.
3, 4, and 5. Okay, good. I want f of A and f of B. What is f of A?
0.
0. Only 0.
Only 0.
Jay, you are not audible.
Sorry. May showing. Am I audible now?
Yeah, you are
Yeah.
audible.
Yes, what is f of B? That's what I was asking. Yeah. Swati was telling, no? Swati, you can tell.
So 0.
0. It's a constant function. So what is f of A intersection f of B?
0.
0. And what is A intersection B?
Empty.
A intersection B is empty. So what is f of A intersection B? F of empty set. Did you try yesterday? What is f of empty set? Adya, what is f of empty set?
Sir, empty.
Yeah, good. Oh, yes. It's empty set, right? So f of A intersection B is empty set. F of A intersection f of B is 0. So do you think this is true? You found an example, right? This is 0. And what is this? Sorry, we are discussing this. So this side f of A is also 0, f of B is also 0. And this is an empty set. How many of you understand this? Clearing the feedback. Right? Question is there. Discuss. Okay, so think about other functions. Somebody said x square. So think about x square. not R2, g of x equal to x square. Think about this, right? So there is a problem when we go in intersection. So, but now notice this, we already have y equals to f of a and y equals to f of b. So I can say that f of a equals to y equals to f of b. So f of a equals to f of b. If a equals to b, then I'm done. Why? Because a is in a and a equals to b. This is in b, this is in a. So if both are equal, then I can get a is in a intersection b. How many of you agree? I'm repeating again. Just observe. We got y equals to f of a and we got y equals to f of b. So that means f of a equals to f of b. Now if a equals to b, then I'm done. Then I found an element in the intersection because a is in a and b is in b, but both are equal. Therefore, a must belong to b also. So a is in a and a is in b because b is in b and a and b are equal. So I have found an element in the intersection. Then I am done. How many of you understand this? The problem was this. Here f of a is, you see, a and b have nothing in common, but f of a is 0. F of b is also 0. Okay, but if we can conclude that a and b are equal, then we have an element in the intersection. Then I can write y equals to f of a, where a belongs to a and a belongs to b, and I can say that it's in the intersection. So this is the condition, right? What is the condition? Something like this. If we have, then we are done. F of a equals to f of b implies a equals to b. If we have this, then we have no problem. Now, if a and b are equal, then I have found an element in the intersection. How many of you agree? If here the problem was a was in a, I don't know what is in b or not. B was in b. Good. So what is this condition? What are these functions? Krishna, can you tell? This type of condition something satisfies?
Yes, sir. 1, 1.
Yeah, so 1, 1 function, right? F is 1, 1. How do we define Krishna? F is 1, 1 if Krishna, can you define F 1, 1 function? No? Charvi, can you define? You know 1, 1 function, right? I already given some conditions. Charvi, yeah. Aisha, 1, 1 function. Am I audible? Gokul?
You are audible, yeah.
Okay.
Yeah.
Yeah. So
Sumanyu?
just 2 minutes. Suman, you tell.
Okay. For every y part of y, there exists a unique x such that y is equal to fx.
No, that's not 1, 1 function. See, I've just already written, right? So done. Yeah. Who raised hand? Ritu?
Given any A and B belongs to A, then
Yes.
f of A equal to f of B, such that
So
A equal to B.
yeah, so good. So I am writing x to y. So general definition. So I'm writing given any x1, x2 in x. Okay. If yes, Ritu, you said if
F of x1 equal to f of x2.
yes, if f of x1 equals to f of x2, then
X1 equal to x2.
x1 equals to x2. Okay. Yeah. Just is there any other condition? Do we check any other way also? Ritika?
So can we just say f of a is equals to f of b if
Hmm.
and only if a is equals to b?
See, a equals to b, then f of a equals to f of b. The elements are same, then it's a function only, right? So
No,
two
sir,
elements are same.
if and
Huh.
only if.
So if and only if you are saying, right, this way, right? But that's same. If a equals to b, then f of a equals to f of b. There is nothing to check here. So we don't say if and only if. images are same, then the elements are also same. This is what we prove, right?
So it will also imply that if f of A is equals to f of B, that will mean that A
A
has
equals
to
to.
be equals to B.
That's what I'm saying. If f of A equals to f of B, f of A equals to f of B, then A equals to B. This is what we are writing. Other way is anyway true. A equals to B, then f of A is equals to f of B. That is anyway true.
Yes.
Okay. Shivam, you have any other answer? Room number 5.
If x1 not equal to x2, then f of x1 not equal to f of x2.
So given any x1, x2 in X, if x1 is not equals to x2, then fx1 is not equals to fx2. Which definition is correct? Which definition is correct? First one or second one? Ayush or Shivam, can anybody say which definition is correct?
Both of them, sir.
Both of them? Why?
Contrapositive statements.
Yes, exactly. See, they are contrapositive. Good. So before I end, yeah, they are contrapositive, right? So yes. So now check this. If f is 1, 1, if f is 1, 1 function, take all examples we have done and try to find functions which are 1, 1. Try to prove this. We have not discussed in detail because last session, if f is 1, 1, then can I say that f of A intersection f of B equals to f of A intersection f of B? So this side is anyway true. Subset is anyway true. We have to check this. Now we have a condition f is 1, 1. Okay, and then it's converse. Okay, and discuss examples also. Discuss examples for 1, 1. Whatever examples we have checked, no, R to R, Z to Z, M to R, 2 cross 2 matrices to real number. So check all those functions which are 1, 1. Okay, finally, I would like to give you this definition that if you have set B here, right, then we have a function f. Then we can talk about pre-images. This does not mean that function is invertible. We can talk about pre-images. But what is this? So all those elements, this is f inverse B, pre-image set. All those elements whose image is in B. X is in X such that fx belongs to B. So we are not discussing in detail, but try to think about this. Take examples and then check with this f of A union, f inverse A union B, is it equals to this, okay, on intersection and all, whether it sorry, this is I have written same thing. So check about this. Okay, so if you get time or if you want to study further, you can refer the book also by Ajit sir, Kumar Singh sir and Baba sir. Okay, so this is just like image, we have a pre-image set. What is pre-image set? All those elements whose image is in B. So all those X here, so that f of X is in B, that is the pre-image set. Okay, take examples and then you can read further, check all this by taking elements here. Okay, so yes, so I stop here, already exceeded time.